Hello, everyone. We'll be starting shortly. I just wanted to inform everyone that we'll be recording this session. And if you feel uncomfortable sharing your video, or in most cases, we would prefer that while the talks are going on, that the video is not shared. But in case we ask you to and you feel uncomfortable to do so, it's completely fine. You could keep your video off. We encourage you to keep your video and audio off during the whole session. Thank you all for being here. We'll be starting in another minute.
And thank you, Professor Peggy, for joining in at 12 a.m. I know it's quite late for you.
All right, it's 11:30, so that's the plan. We were supposed to start in now, and with that, I would like to welcome everyone who's here. Thank you so much for joining the Neuro November convention. This is the first youth-led international neuroscience convention from India, and we're really proud of this convention. I am Shreya Naidu from Stimulus.
I'm Amartya Pradhan from Project Encephalon, and we are the conveners of the Neuro November Convention.
So just to go a little bit about NeuroNovember is a collaborative effort by Project Encephalon and Stimulus, who are the two leading youth-led neuroscience initiatives based out of India. This convention is fully run by volunteers involving high school students, undergraduates, graduate students from diverse backgrounds. NeuroNovember stemmed from the idea of reaching out to neuroscience enthusiasts, amateurs, and experts alike. This convention aims to bridge the gaps between schools and universities, researchers, and the general public, the represented and the underrepresented communities within neuroscience and STEM in general. This convention is not only limited to bridging the gaps, but also addressing the key issues underlying neuroscience, including diversity, translation of jargon-heavy lab work to the public via science communication, empowering the upcoming generation, and in doing so, bringing them on to the mainstream.
So hold on while we take you on a 4-day journey spanning 2 weekends where we explore the realms of neuroscience in allied fields through intriguing talks, enlightening panel discussions, workshops, exciting competitions, and we hope that you'll make the most out of these. Without further ado, let's get started with the very first day of the Neuro November convention. Many people, including myself, have started their journey in neuroscience listening to the lectures of our keynote speaker, Professor Peggy Mason. Dr. Peggy is a neurobiology professor at the University of Chicago. She received both her BA in biology and her PhD in neuroscience from the Harvard University. After postdoctoral work at the University of California, San Francisco, she joined the faculty at the University of Chicago in 1992. She is an award-winning teacher and the author of a neurobiology textbook titled Medical Neurobiology. Dr. Mason's research focuses on the neurobiological basis of helping in rats. Professor Peggy, we are extremely happy to have you on board as the keynote speaker for this convention. I invite you to take over this platform.
Great. Well, thank you so much. This will stop others. Yes. Okay, here we go. Great. It's lovely to be in India. I mean, one of the wonderful things about the pandemic is that it has made everyone think more creatively about how we can communicate. And as my friend Shuba and I have talked about the possibility of me coming to India, and that never actually happened, but now I feel as though I'm visiting, so it's wonderful. And I really congratulate you for making this this initiative led by you, young people who are interested in neuroscience, which is really why I ended up teaching the MOOC, is because I wanted to have people that were just interested in neuroscience for the sake of being interested in neuroscience have access to that. So I'm just thrilled that you're interested, and I'm thrilled that you've done all this work to get this convention together. And I really congratulate you. Okay, so to tell you a little bit about what I've been doing for the last 10 plus years. I show this slide, I think you can see my cursor. This person right here is Inbal Benami Bartal, and she was a graduate student who started this entire project. So I want you to, that's the first lesson here, is that you can have an idea. This was not my idea. This whole line of research, which now dominates my lab, it came from Inbal. It was her idea. So she was working in the psychology department on empathy in humans, and she sort of got sick of humans and wanted to look at the biological basis of empathy. And so to do that, what do? You try it out in a rat. And at the time, what we knew was that one rodent could catch some affective state, such as fear, from another individual. And that would be the very basic form of empathy. It would be what we call emotional contagion. It's like one baby cries, all the babies cry. So an individual sees another individual who's scared, and even though that the viewer has never experienced anything scary, they also now feel scared. So they're catching that affect from another individual. Well, that's wonderful, but it's all internal. And what we wanted to try to do is to see whether we could, whether rats would take that internal state and do something with it. So in this case, what Inbal wanted to see is whether they would use empathy for another's plight as a motivation to help. So that's what we're going to talk about today. The background and I'll very briefly go over our evidence that rats help, just the early work that we did. And then I'm going to present work that we published this past summer on the bystander effect, because I think it's very interesting and particularly applicable to the human condition. And I would advance that one of the great things that one of the great challenges for humankind is, why can't we all get along a little bit better? Why can't we help each other and be more cohesive in a social way? So that's what we're going to do today. So we'll start with the background. So as I said, what we're looking for is a way for rats to tell us if they want to help another. And what we ended up designing was this. Is a restrainer that sits in the middle of an arena, and you see some of the arenas down here. Here they are. And in the middle of the arena is a restrainer, and there's a rat that's trapped in here. And this rat cannot get out because the door doesn't open from the inside. It only opens from the outside. And the first thing that we do is we just put this free rat out here, and we can't tell the rat, go help your cage mate, or go help the other rat, the trapped rat. He has to just decide that that's something he wants to do. And then he has to not only decide that he wants to do it, but he has to figure out how to do it. And opening this door might seem like a pretty simple thing. In rat land, it's not that easy. It's actually fairly difficult. So even if we put chocolate in there, say, it still takes them a few days to figure out how to open the door. Okay, so what happens? So here is a video, and it's a 2-minute video. So what I'm going to show you, this will give you a whole sense of how this whole thing works. Whoa, that wasn't good. Let's try that again. So here, this is sped up, the first day of testing. And what you can see is that the free rat keeps on going into the middle to see the trapped rat. And that's unusual because the middle is a very scary place for rats. They really like to stay on the edges. So it's remarkable that he goes into the middle, but he doesn't know how to open it. Now, here we are, and hopefully you can hear a little sound. And this is the 5th day of testing. And you're going to see him open the door. You're going to see the free rat open the door, which makes a sound. And when it falls over, the 2 rats are going to freeze. Okay, right there. You see that? That's not a glitch in the video. That's them freezing. And they're freezing because they're surprised by the sound. So, and the next thing we're going to see is not day 5. We're now going to speed up to day 12. So here's day 12. This is real time, starting right when the rat's put in, and you can see that all he does is he wanders around for just, some seconds to figure out this is the same situation as yesterday, the same gig as yesterday. And now what am I going to do? I'm going to open the door, and there's no freezing. And the reason there's no freezing is that because both rats are expecting that door sound. They know exactly what's going to happen. The free rat is making an intentional act and knows what the result of that intentional act is. There will be a sound when the door falls over, and the trap rat will be released. So this is an intentional act. Okay, so I don't have time to show you the data here, but suffice it to say that we tested for whether the free rats would open the rats just in order to play with a trapped rat. We got the answer no. Naboya Sato did this a different way in 2015. He also found no. And Cox and Reichel just published a paper this year showing once again that this is not done just simply to play for the other rat. If they're looking at a rat that's not in distress, they don't open the door. So this is an action that you need a distressed rat. And I haven't told you, but early on we did lots of controls. So for example, rats don't open for an empty restrainer, and they don't open for a restrainer that has, say, a toy rat in it. So they're opening for a rat that is trapped and in distress. Okay. So how big a deal is it? And this is the last piece of the intro that I'm going to show you. And what I'm going to show you is sort of what's the floor and what's the ceiling. It's always useful to know what your parameter space is, right? Where are you operating? And I have no idea what that was. Oh, so the floor is if there's no rat involved, and the ceiling is if they're helping themselves. So if the floor is if there's a empty restrainer. So how often will they open for an empty restrainer? The answer is not very often at all. And then the ceiling is if we turn the door around and now they're opening the door for themselves, that's the best that we can expect. So it would be lovely not to have this writing on here. I don't know what happened there, but Okay, so what we see on the left is the median latency. And here is an empty restrainer. Whoa, oops. Oh, let's go back. Okay, here we go. So here is the median latency is on the left. And if this restrainer is empty, the median latency is 40 minutes, which is how much time we give them. So no one opens, or the median opening is not opening. And if instead they're releasing themselves, you can see that the first day, the median latency is a little over 15 minutes, but by the second and third day, certainly it goes down basically to 0 minutes. And on the right, what you see is the percent of rats that open. And when they are opening for a, I have given permission to annotate. I don't know how I did that. I don't know how to stop that. So the percent opening, what percentage of the rats open on each day of testing? We test them for 12 days. So if there's an empty restrainer, no one opens, and on the very last day of testing, 1 out of 16 rats opened. So we wanted to ask, well, is that the beginning of something? Has this rat decided that opening for an empty restrainer is a fun thing to do? So we tested them for 1 more day, and as it turns out, none of the rats, including the one that had opened on the 12th day, none of the rats opened on the 13th day. So that's 13 days times 16 rats, and 13 times 16, there was in that number of tests, there was only 1 opening. So in other words, they don't open for an empty restrainer. Really not appealing. On the other hand, virtually all of them open for an empty restrainer. Now, it's worth noting that of the animals that were tested with the empty restrainer, 15 out of the 16 opened, but 1 decided to hang out there. So in other words, the restrainer, oh, thank you for doing that. The restrainer is not a horrible, it's not the worst thing in the world to be. And, there was 1 rat in 16 that was okay with it. Okay. So that's where the parameter space, that borders of the parameter space are. So how about if we put in a trapped rat and a free rat? What happens? Well, what you see is that it exists in between those 2 spaces, in between those 2 borders. They start out as though they're being tested with empty restrainers. They don't open, but they very quickly switch over to being basically the same as opening for the self, very close to it. So these are just these different shades of red are just different cohorts of animals. And there's some variability, but what you see for each one is there's a switch, and that's going to be shown in a different way in the next slide. So in this slide, each row is a rat. So each row is a rat, each column is a day. And if they open once and only once, it's a yellow. And if they open 12 times in a row, which in this group of 24, there were none that opened for 12 times. But if they did open for 12 times, it would be a perfect red. And so what you see is that once they open, they almost invariably open the next day. And once they open twice, they almost, it's over 95% that they open on the 3rd day. Once they open for 3 or 4 days, it's basically 100% that they're going to open on the following day. And so what you can see is that there were a few instances here where they did not open on the next day, but the vast majority of the time they're opening the next day. And so what does that tell you? It tells you that this is a reinforced behavior. This is a behavior that they had such a good time on the first day of opening that they decided to do it on the second day. We are not giving them any reward. So this is entirely because of their internal experience, the internal reward, if you want to put it that way, that they experience upon the first opening. They have such a good time. Let's do it again the next day. Okay, so now let's switch over and look at what is the bystander effect. Now, the bystander effect was first explored by Bib Latane and John Darley, and they were inspired by a couple of really horrible stories about crimes. And one of the stories is a story about Catherine, typically referred to as Kitty, but Catherine Genovese, who was raped and murdered in Kew Gardens in New York City. And it was a March night, and the story that was published the next day or that week in the New York Times was that there was 30 some, more than 35 witnesses to this crime, and none of the witnesses did anything. None of them called the police, and none of them interfered, or none of them intervened. And so as it turns out, and we can talk about this more in the discussion, as it turns out, the story's wrong. It's just factually absolutely wrong. It turns out that very few people heard or saw anything, and maybe 2 or 3 people might have heard something. It was 2 or 3 o'clock in the morning. They were asleep, and it's just not, it does not appear to be a factually true story. But we can get back to that. Nonetheless, what Latane and Darley did, and these are 2 psychologists at Columbia, and what they did was they did a series of experiments to see how the presence of other individuals influenced humans. So, for example, this is just a really good example. There's a really clear one. If there was a person alone in a room and they were filling out a questionnaire, which was a distractor, it was nothing about the questionnaire was neither here nor there. It was just to get them in the room. And they had smoke come in through the vent in the room. And 75% of those who were alone in the room went, got up, put down the questionnaire, got up, left the room, reported that there was smoke coming into the room. This is a problem. On the other hand, if they were in the room with others that are called Confederates, these are people that work for the research team and are just sitting there not doing anything, so they're not noticing the smoke. In the presence of these Confederates, only 13% of the subjects actually got up and reported the smoke. So clearly people are influenced by the behaviors, the perceived behaviors, the perceived attitudes of others that are present. And what we were, and this actually became this idea of the bystander effect, which is, if to state it clearly, it's that the likelihood of helping when alone is much greater than the likelihood of helping when one is in the presence of others. So groups are less likely to help than individuals. And that is called the bystander effect. It's part of the psychology canon. It's present in every psychology textbook. So, and it's thought to be due to things such as a diffusion of responsibility, which is a very high-minded idea. And I had always thought, what about rats? And so it turns out that I had a student, John Havlick, who I'll introduce in a moment, who sort of took me up on this. I'd thought about it, but I couldn't figure out what the experiment was. And he just was so interested in doing this that he said, Peggy, let's do it. Let's do it. So here's John. He's now a second year student at Yale Medical School. And he initiated it. He just pushed me until we got it done. And he was joined by Mara Clement, who's now a physician in Minneapolis, Yuri Sugano, who's I guess he's a third year at University of Chicago, Rahul Kukreja, and John Jacoby also were involved in this. So what did we do? Well, what we did was we recapitulated the human experiments, which is to say, will a rat help? We know that one free rat will help a trapped rat. What if there are Confederates sitting there in the same arena with the free rat? And to make a Confederate, we can't tell the rat, don't help. So what we did was we drugged the rat so that they wouldn't help. And so this is what it looks like. We gave them midazolam, which is a benzodiazepine. And here's the red guy is the active rat. And this N guy is the midazolam treated rat. So this is on day 4. And you can see that the active rat goes and he's interested in the trapped rat. Here on day 7, after he's already opened, he's not interested anymore because, and I'll show you these data. And we did this with either 1 or 2 midazolam treated rats. So in this case, the blue and the red and the blue are both midazolam treated, and the green is the free rat. Okay, so what happens? So in this, what you're looking at here is on the y-axis is the number of consecutive openings. That means you open on one day and you open on the next day. And on the x-axis is the total number of openings. This dotted line is perfect. If every opening is followed by another opening, then if you open 12 times, 11 of those openings are consecutive. And so that's this dotted line. And you can see that the control rats fall exactly on the dotted line. They behave perfectly reinforced. Every time they open on the next day. What happens in the presence of Confederates? Well, if there's one Confederate, this is where they fall. They're not on the they're off the dotted line, so they're not perfectly reinforced. And here's if there's 2. So in this case, with one Confederate, they open a total of, on average, about 5 times out of 12 possibilities. And with 2 Confederates, they open 4 times. And most importantly, with 2 Confederates, they only open consecutively once. That means 1, 2. On average, they're only opening once consecutively. So they're not doing this thing that we saw with the control rats. So, so the next thing we wanted to do was to say, well, do they listen to any Confederate rats? Do any Confederate rats influence them in the same way? And I have to digress just a touch to explain this experiment. How am I doing on time? Okay, so this, what we found was that all of our experiments that I've told you so far are on these albino rats, and we asked the question of whether they would help a black cape rat. Here's a black cape rat. It's a different type of rat. And under normal circumstances, an albino rat never sees a black cape rat. And what we found was that albino rats will only help black cape rats if they've lived with at least one black cape rat. we can explore this a little bit more later, but just to give you a flavor for how this works, if you take albino rats on the day of their birth and you transfer them to a black-caped rat litter, so they've never met another albino rat, well, they will help black-caped rats in that situation and not help albino rats. So it doesn't really matter which type, whether it's their biological type or their genetic type or not. What matters is who have they had experience with, and they will help any rat from a strain that they've had experience with. Okay, so now what we're going to ask is, are they influenced by black-caped rat Confederate rats? Okay. And what we did was we had two groups. We had rats that had lived with a black-caped rat and rats that had not. And the rats that had lived with the black-caped rat did not help. So they paid attention to the black-caped rat Confederate, whereas an albino rat that had never seen a black-caped rat behaved just like a control and helped, even though there was this black-caped rat sitting off on the side, not doing anything. So the albino rat is not influenced by a type of rat that it has no experience with, no familiarity with. And that's a really interesting experiment that has obvious implications for humans and has never been done quite as cleanly as this in humans, because it's not that easy to do in humans. Okay, so that was a really exciting finding. And then, so what this tells you is, let's just focus on this right here. This is the number of consecutive openings out of the total opportunities for consecutive openings. And this group is the controls. This is if there's this is if it's a long Evans, if it's a black-caped rat, and they're unfamiliar with them. So that black-caped rat is essentially not there. They don't pay attention to it. So these are just like the controls. And then what you have down here is the one or two Confederate rats that are of a known type. And so what you see is that what the Confederate rats do is they decrease the reinforcement. They decrease the good feeling that the rat got from opening. It's as though the rat says, well, I opened yesterday and no one cared, so I'm not going to open again today. Okay, so finally, we asked the question of what is the effect of naive bystanders. So what we've looked at is what's the effect of Confederates, these bystanders that are not helping, but what's the effect of naive bystanders? And that turns out to be a completely different story. It turns out that in the presence of non-drugged animals, what you see is that they help even better. So now you might notice that here's the control. This is the same thing where it's consecutive openings versus total openings, but instead of being for 12 days, it's for 6 days because they all open in 6 days. So the controls are way down here because in 6 days they open much less. When it was 12 days, you saw the controls up here, but for 6 days they don't open as many times. And if there's one extra rat, they open more often. And if there's 2 extra rats, they open even more often than that. So it's having the opposite effect as Confederates. It's facilitating opening. And I think I'm running out of time, but just to say that one of the possibilities that is why they're opening more is because there's more rats. But you can mathematically test for that by seeing how often that one opens and saying how often then would you predict that 3 independent rats would open. So we did that. We compared, we have all these single rats testing in the regular paradigm, and we just sort of shuffled them. We put them into artificial duos and trios, and we compared that to our experimental data. And what we see is that the experimental duos open much more often than the shuffled duos, and the experimental trios open much more than the shuffled trios, only on the first day. So it's all about that first day. That's when they get it. And then thereafter, they appear to be at least as reinforced. And we actually have some evidence that they're even more reinforced in the presence of others. And let me show you that evidence here. So, first, let me just say that this fits with a lovely study that came out of Mark Levine's lab, showing that this was they used cameras that were security cameras that were just taking pictures of the street in 3 different countries. And what they found was that when there were violent altercations, in over 91% of those altercations, bystanders would intervene. And on average, there were 13 bystanders, and on average, 3.75 bystanders intervened. So it's a very, so this fits with our, it's not an exact comparison, but it fits with our finding that groups of untreated, naive individuals are more likely to help than single individuals. You can imagine that a single person coming upon a violent altercation in the street is unlikely to help, not at, or certainly not likely to help at a 90% level, although they did not test that, but we can guess that. Okay, so our finding fits with results, very recent results. This is from 2019 by Mark Levine. At least one bystander intervened in 91% of the situations, with an average of 3.75, 3.76 interveners. And so here's what I told you, that it looks as though they're more reinforced in the presence when they're in these groups of naive rats. So what you see here, what happened with these trios is that they opened so much that by day 6, there was no point in continuing the experiment. So what we did, excuse me, was we stopped testing them as a group and we tested them individually. And so in red here are these trio rats, and on day 6 they were tested as part of a group, and they opened. But on day 7, most of those rats that had opened on day 6, when they were tested individually, no longer opened. This never happens with the control rats. So with the control rats, if you open on day 6, you always open on day 7. And this effect persisted, so that on days 8 through 12, the control rats had an average of 5 openings, 8, 9, 10, 11, and 12. And whereas the animals that had previously been tested as part of a trio only had 3 openings on average. What this suggested to us is that the rats like the audience. So they opened, the other rats said, "Hurrah for you." They felt good, and they opened again, and they opened again, and then they lost their audience and they stopped opening. Now that's pretty remarkable. And it tells us that, in fact, when you that you can influence another individual's actions simply by your reaction to their actions. So this is finally some of the people over the years that have done this work. many people, mostly undergraduates, I will say, mostly college students, contributed to this work, and I'm indebted to them, and it's been a really, really fun journey. And finally, I think all of you will resonate with this idea that it's never too early or too late to learn neurobiology. It's the greatest subject in the world. And I really commend you for finding your way to neurobiology at such a young age, because it really makes for a beautiful life. And I'm very happy now. I'm going to get out of that. And stop the share so I can see you and answer some questions. And I would love it if you showed me your faces. And okay, so let me see. I'll take a question. If somebody wants to ask one live, that's fine too. What is the sex of the rats? Well, so for reasons that are historical, we were using male rats because in a previous, my work at the time that we started this was on male rats. And so we've done it with female rats. It works with female rats, but all the controls have been done with male rats. So we sort of have gotten ourselves into a rut of doing that, which is unfortunate, but true. Why can't the rats used for the study be tested in a natural environment? Be lovely. I mean, one of the things I would want, a natural environment would be great, but even better, in my opinion, would be wild rats. I'd love to test wild rats. They're really smart. So our rats, haven't had that much experience with things, with life, with objects, and so it takes them a few days to figure out how to open the door. I think wild rats would get it in a second. So we'd have to tweak the paradigm because they're too bloody smart. But these are great things to do. There's not an infinite amount of money in the world, so you have to prioritize what experiments you end up doing. Why is the opening of the door associated with a feeling of joy rather than a sense of relief? So this is a good question. So what is the feeling? Well, I don't know what the feeling is, but what I can say is that the rat that experiences the feeling is the opener and not the one that's opened for. And that's pretty interesting. So the one that's opened for does not appear to care, just goes around and explores the arena. The one that opened is very excited and shows this very characteristic increase in velocity that lasts for about 10 to 15 minutes. And you saw in the video that the free rat that has just liberated the trapped rat will follow the trapped rat, jump on the trapped rat, lick the trapped rat. This is always the direction. It is never the reverse. When we did one sort of exploratory pilot experiment to see whether the trapped rat preferred a rat that opened for him over a rat that didn't, and the answer is no. So there's zero evidence for gratitude, for what we would call gratitude. And if you look at the primate literature, that also is true. People such as Franz de Waal have never seen any evidence for gratitude in monkeys. So it appears, and I think that what this is telling us is that I don't know if you all have the expression, but we have an expression: to give is to get. Do you have that expression? Yeah. Okay. So, I mean, there's a lot of truth to that, I think. And I think the rats show that there's truth to that even in rat land. So this is a very basic biological principle that to give to another is rewarding. And that makes sense because it's evolutionarily advantageous. And so you want to make it feel good. What will be the effect of how the rats have been reared since birth, grouped versus isolated? Mammals shouldn't live in isolation. So it's such an artificial experiment that I won't do it. The rats aren't going to be happy. I don't like unhappy rats. It's, I don't believe that mammals should be isolated. I don't think prisoners should be isolated. I don't think rats should be isolated. It's just, it's an extreme measure. We don't do it. So I don't know. It wouldn't be good. They're weird. Isolated animal. I mean, we have plenty of data to show us that isolated monkeys, isolated rodents grow up with a lot of anxiety, a lot of social weirdnesses. And I don't think we need to prove that again. As you mentioned, the drug rats show bystander effect. The knife were as efficient in opening the doors as controls. Did you study further the effect of drug on the rats? The drug was just a means to an end. We just wanted to use the drug to get them not to help. If I could have given them a lecture and told them don't help, I would have done that, but I can't. They don't get it, so we had to drug them, and that was really the only point. What if there are two trapped rats and one on the outside? Will that rat help, or will it think that the pair doesn't need any help? Two trapped rats won't fit in there. What we have done is we've done two restrainers, one with a trapped rat, one with chocolate, and they open for both. And they appear to care as much about opening for both. So they, some days they'll open first for the chocolate, some days they'll open first for the trapped rat. So which that suggests that opening for a trapped rat and chocolate are on a par. I actually think that opening for a trapped rat is slightly more rewarding. And I can tell you why I think that if we get there. Let's see. In the beginning, there seemed to be an interaction between the trapped rat and the released one. The released one following the other. This doesn't seem to happen once they're habituated. Is it so? Is there a reason for that? So it's actually the free one following the released one, the free one following the liberated one. And yes, that what we call the celebration, it is that what we see and we call the celebration is exactly the same behavior that Larry Young and James Burkett saw and called consolation behavior. They published a paper on consolation behavior. It's exactly the same behavior. So whether, these are just semantics. This is just what you call it. But that behavior of following is exactly the same. And it does subside. The first time is the most rewarding, exciting. And by day 12, it's muted. It is true. One of these days, I would like to quantify that a little bit more. That's still a little anecdotal. So do you think the free rat would have any expectation from the trapped rat such that in the future, in case the free rat were to be trapped, the other one would help it get out? So we didn't do that, but Nobuo Sato did a version of that, and a rat that has previously been trapped is a better opener, a better, faster opener. It's as though, oh, I know how bad it is for you. I'm going to help even faster. So yeah, that is for sure. Since shuffled rats showed better consecutive openings than experimental, it's actually the opposite. The experimental rats show better consecutive openings than shuffled rats. So yeah, so it's the experimental. If you shuffle a lot of single tested rats, they don't perform. You just put, this single rat, artificially you combine this single rat with this single rat with this single rat. They will not open as much as 3 rats that are actually tested together, which shows you that the 3 rats tested together are not acting independently. They are acting dependently. They are influencing each other. They are facilitating opening in each other. Okay. Let's see. Is it necessary for the rescued rat to interact with the rescuer in order to reinforce the behavior in the subsequent days? So no, I mean, so the way we did this was, if you put two arenas together and you put the restrainer, the tube, up against the divide that goes between the arenas, when the rat opens the door, the trap rat gets out to a different arena and they can't interact. And the free rats will continue to open as long as there's a trap rat in there. So he doesn't have to actually play or interact physically with the trapped rat. Can we use neuroimaging techniques? You can. It's pretty, it's not the greatest in rats. and you know, this is a complicated paradigm that takes place over 12 days. And so you sort of have to think to yourself, at what point am I going to take these pictures? What point in time do I want to look at? And on day 1, I don't know what's going to happen on day 6. So if I take a picture on day 1 and I can't continue to use the animal, I don't know whether that animal will become a great opener or will be one of the 25% of rats that don't ever open. So anyway, that it's a sticky little problem there. What if the trapped rat was a female and I'm assuming you're saying the free rat was a male? You know, I mean, that's sort of studying sex. That's studying mating rather than studying helping. So we haven't gone that route. I actually think the real floor, the problem with the floor that we did was that the door is reversed and it's a much easier task because the trapped rat is just sitting there and he knows exactly where the door is. There's only one way to go. A better floor would be to have a mom on the outside and pups on the inside and see how long it took her to open the door for pups rather than for a mate. But we haven't done that. Yeah, that would be sort of a fun experiment. Let's see, do brain dopamine levels change during this behavior? Inbal actually has some data on that, and I think it will be very interesting. One would imagine that because this is such a heavily reinforced behavior, it's hard to imagine that dopamine is not released during at least that first opening. We actually also have we have data showing that the host has okay, you want me to be like that? I was enjoying seeing all the faces.
Okay.
Yeah, right. So we have some data that, in fact, opening the door becomes a habit after only 2 openings. So do you all know what a habit is? A habit is something that is outcome independent. You know, the first time a person takes heroin, it feels really good. And the second time it still feels good and it gets reinforced. But by the 10th time taking heroin feels like crap. It feels terrible. They still take it. They take it even if it feels terrible. That means that they are taking it even though the outcome is not desirable. That's a habit. And so to test whether opening is a habit, what we do is after they've opened twice, we give them an empty restrainer and they open for the empty restrainer. So that they no longer need this outcome to do that. What's very interesting is They do that after 2 times. They do not, opening the door to get chocolate is not habit forming, not in 2 times. So we did this experiment, and it's very hard to get them to form a habit. Very few of them form a habit from opening for chocolate, which tells you that opening for chocolate is less reinforcing than opening for a trapped rat. And then with this one rat, who opened for chocolate twice, and then we gave him an empty restrainer for 10 days. He never opened the empty restrainer. Then we gave him a trapped rat. He opened for the trapped rat twice, and then we gave him an empty restrainer again, and he opened for the empty restrainer, which shows you he couldn't form the habit from opening for chocolate, but he could form the habit immediately after he opened for the trapped rat. So, so this is a really reinforcing activity. Let's see. What's the habit difference between habit and addiction? Habit is a biological term. That's what it means. It's outcome independent. Addiction is more of a social version of that. The need to continue in to take some substance to feed a habit. Let's see. Does it matter if the drugged rat and the trapped rat are both the out group? Yeah, so that we haven't done that. One of the problems with doing some of those experiments is that the black cape, we always use the white albino rats as the rats that are doing the opening, because the black cape rats are smart. They're smarter than the albino rats, and they sort of open. They learn how to open too quickly. So there's sort of no dynamic range for the experiment. So that we could change it. We can make the opening more difficult. I don't know if you noticed, but there's a counterweight on the door. So if you take this counterweight off, it gets more difficult. But it would just take a little fiddling with it to make that work, and we haven't really done that. Okay, what else? Are there other questions? Anyone want to actually say a question verbally?
Yeah, if anyone would like to. All right, Pragya, you can go ahead.
What's that?
So Pragya raised her hand to probably ask a question. Pragya, can you unmute yourself?
Thank you.
Yeah.
Can you guys hear me?
Yep.
Yes.
Yeah, so this is coming from a personal bias because I've recently started working with circadian rhythms. And I just wanted to know, because there is a rhythm when it comes to cognition and anxiety levels and things like that, do you think that will have an effect here?
I'm sure it would have an effect. And we've done, along with the fact that we're only testing male rats, I'm not particularly happy about the fact that we test the rats in the light part of the day.
Yeah,
it's
yeah.
wrong.
Yeah.
Test them in
Because
light.
they're nocturnal animals, and a lot of times all of these behavioral studies are done during their, to say, rest period.
Yeah, so it's just way easier for the humans, but it's wrong. But it's a sufficiently robust paradigm that it works. Would it work better at nighttime? It would work better, but again, you sort of risk losing a little bit of the dynamic range. If they're really awake and really good at it, they might get too fast at it. It's kind of, we're sort of at a sweet spot. But yeah, these are great things that, ideally we would be doing. Ideally, I would have it in an enormous room where they had to go, it was a room, the whole arena was a room, and they had to go into the center. That's really hard for a rat. So, you know, there are lots of ways you can improve it, but then you also have to live with some realities of what's feasible in a laboratory setting.
So earlier I
So,
asked,
so actually,
sorry.
somebody just asked, is the age of the rat a factor? And it's interesting because it looks like this also, this is work that I hope will be published soon. I just reviewed it. It looks as though young rats can do this. So our paradigm doesn't work with young rats because the tube is too big. But somebody adapted it. They modified it a little bit, and it's an acute experiment. And yeah, young rats, juveniles will do this too. Obviously, it has to be a door that an animal of a certain size can open. So, yeah. Did you have another question?
Oh, no, earlier I had asked about isolated versus group. So that was me who asked that. And I asked that because isolation is sort of, I mean, I don't know if I'm correct, it is used as a paradigm to induce anxiety in some cases. And we know that in humans, anxiety can sometimes affect how much people develop empathy. And that is why I wanted to know how would that affect in
We
this
can
case.
kind of get at that a different way. Again, I'm just not doing isolated rats.
Yeah.
It's too much. It's like a hammer.
Yeah.
You know, it's not subtle. It's way too big a effect. But we asked, here's a different way to look at it. There's about 25% of the rats that don't ever open. And so there's two possibilities. There's two basic possibilities. One, they're psychopaths and they don't care. Right? Care so much that they're immobilized. So what we did was we took the rats, we exposed them to a trapped rat for 40 minutes, and the door was shut. The door was closed, so they couldn't open it. So they got this 40-minute exposure. We measured their corticosterone. Then we took them through the whole paradigm. And what we found was that the non-openers had the largest corticosterone responses, which fits with what you're saying. So the ones that have the biggest reaction are the ones that they're too self-anxious. They're too self-oriented. They can't, if you are so anxious and so affected by seeing something, you cannot be other-oriented. And helping is essentially an other-oriented action. So that's another, so absolutely. Anxiety, big player. Big player.
Thank you.
Yeah.
Thank you, ma'am. Thanks, Pragya, for coming in. Aditi has a question for us right now. She can unmute herself. Can you unmute yourself, Aditi?
Yeah,
Alright.
I'm audible.
Yeah.
Yeah.
Hello, Peggy.
Hi.
My question to you was something like, since this experiment was going on, what I understood from this experiment is that we are trying to understand whether the rats are having some kind of a primitive emotion kind of context or not. So, like, should we, if there is a primitive emotion in them, are they conscious as well? Like, can we consider them as
Well, I don't know what it buys you to call it primitive.
like
I mean,
having
I don't know what it tells you that it's primitive. It's a rat affect. Is it the same as ours? I'm sure not, but I'm also sure that my affect is not the same as your affect.
yes.
You know, so it's rat affect. It's different. I don't know that it's worse or better or more primitive or more developed. It's just different.
Okay.
And are they conscious? You know, my flavor is yes, but who knows? That I think that's not something I can tell you. I don't think consciousness. I think consciousness is going to be a little bit of a personal preference where you
Okay.
see that. You know, in general, I'm a big believer in evolution.
Hmm.
What evolution tells me is that we're animals. And we're very good animals. We're very good mammals, actually. And I just don't see a chasm between us and other other mammals. So, you know, people have tried to say, oh, only humans do this, that, or the other. And yeah, only humans speak English, but beyond that, there's not too many things that only humans do. So I just see it being very likely that what is present in us is present in some form in other mammals. That's
Okay.
my guess, but I would never, I would never presume. It's a very fundamental, it's more philosophical than neurobiological at this point.
Yeah.
So
Yeah.
I would never presume to tell you what you should think. I think you should make up your own mind.
Okay. Thank you. Thank you so much.
Yeah. Yeah.
Thank you, ma'am. Thank you, Aditi. Thank you for coming in. Ma'am, we have some more questions in the chat box if you'd like to address them.
Yep.
Uh,
So how would you interpolate the rat behavior to humans? And so, you know, I don't know how much of the United States, I don't know, politics and doings you follow in India, but this past summer we had a lot of unrest because of police violence against Black people, and there was one of the big cases was a man named George Floyd, who was murdered by one policeman. And as that policeman murdered George Floyd, 3 other policemen stood by and did nothing. And I think they're the perfect example of the bystander effect. So in this case, they're not drugged, but they're trained. They are trained not to intervene with their coworkers' activities. And in contrast to the inactivity of the police officers was the attempt on the part of just regular people walking by to intervene. And they act just like our naive bystanders. They want to intervene, they want to help. So yeah, I see this as 100% applicable to humans. And then we layer on a lot of stuff on top of that, a lot of culture on top of that. But it's fundamentally, it's critical to understand that fundamentally we're meant to help. We've biologically inherited this motivation to help another who is in distress. That's a big deal. Can increasing the area of the boxes in different sets of experiments give us an idea of how far they are willing to go? Yeah. That's, yeah. How far are you willing to go is one of the ways in which I think of that question, and I like that question, is what's the value of helping? What will you pay to help, right? And so we did an experiment, which you know, this is done and I could write it up in a second, but I haven't. And so we had these animals, and they had learned how to open the door, and they were helpers, and they were doing it every day. And then what we did was we separated the tube, the restrainer, from where the free rat was with a corridor. It was a little hallway that had a pool. And in the pool, we put oil. And the rats, I don't even know how they knew it was oil, because we could not even, they didn't put a paw in it. They might have touched it with their, with their whisker, but they would not go down the core. They would have none of it. The minute we changed the oil to water, they walked right through and opened the door, which tells you that the value of opening the door is somewhere between walking through oil and walking through water. Now, you could do that a lot more elegantly by, instead of making oil or water pool, you could make that runway a different temperature. And you could say, in degrees centigrade, what's it worth to you, rat? How much will you pay? You know, will you pay 47 degrees? Will you pay 48 to go get your, you know, to go open the door? And I think that's an experiment that I've always wanted to do. I even have the little doohickeys that will heat the floor. So that's just kind of waiting for a student to do it. That's a fun experiment, and it opens up a whole realm of other experiments, because then you can see. Right now, all we have is a threshold. Do you open or do you not open? But this would tell us, what are you willing to open? Maybe you're willing to open more for a, you know, for your brother than for a familiar non-kin. And maybe you're not as willing to pay as much for a stranger. They'll open for all of those people, for all of those individuals, but maybe they'll pay different amounts for those individuals, and we just don't know. So that's how you could find that out.
That sounds like an amazing experiment and a spectrum of behaviors that we can see in empathy just there. I think a lot of people are saying it's a cool experiment. Ma'am, we have Ankush who wants to come in with his question. So Ankush, could you unmute yourself, show your video?
Oh, she already answered my question.
Oh, okay.
Okay.
All right. So I guess there are no
So
more
what
questions.
drives the rats to, let me just answer this one other question. What drives the rats to help? Is it morals? And it's not morals. It's biological. And that suggests that that's what drives you to help too. It's not because your mom or your dad taught you to be a good person. It's because you inherited it from mammalian evolution. That's why you help. You're very uncomfortable with another individual in distress, and it makes you feel good to help. And then, you know, and then we tell ourselves various stories, but our experiments would suggest that the rats are helping others in distress. We're probably doing it for the same reason the rats are doing it. Great. I think we've gone over time. Have we gone over time?
Ma'am, it's completely fine.
It's right. Okay. Yeah, is it genetic or epigenetic? Yes, probably both. It's epigenetic and genetic. And, you know, the other piece of biology that sort of gets lost in our emphasis on genetics is experience. You know, the nervous system gets set up because of experience, and we learn stuff. And so that's probably a huge piece of it. And Shuba will tell you more about development.
Hi, Peggy. Amazing talk.
I was hoping I'd see you. There you are.
Well, not quite ready in talk mode, but here.
How are you?
Very well. Cooking in parallel, if you would believe it.
Okay, lovely to see you. I think I'm going to be I'm going to be asleep by the time you're talking. I'm sorry about that.
I'm sure. It's great to see.
This is very past my bedtime. What?
I can imagine.
Yeah.
Well, hi to everybody. See you soon enough.
Thank you for coming in. Yeah, Martha, please.
I was saying that, by the way, we are recording these talks. So if anyone wants to go over them, like later, we will send it to all the registered participants.
Okay.
Mm-hmm.
Any other questions?
There's one more.
Yeah, we have another question by Manvi Jain.
I completely agree with the advanced smartness of the human brain as a result of evolution that is explained by neuroplasticity paradox. How can we assume that evolutionary advancements would also make mice smart as us? I mean, well, first of all, it's rats, but mice evolved too. I mean, what you have to realize is that rats are perfect. They're just perfect. They're perfect for their niche. You know, aardvarks are perfect. Little squirrels are perfect for their niche. They're smart for their niche. And we are smart for our niche, but we're not better than them. I mean, I'm not better than a squirrel at figuring out how to deal with acorns. I can tell you that. They're better than me. So I don't think we can. I think there's remember that evolution does not go towards humans. Evolution goes out as a tree, and all those little endpoints are great. They have all survived to today. That's success. And however you get there, I guess you could call that intelligence or appropriateness. Somehow they're doing well. So I don't think we need to compare smartness. If a rat is put outside the whole transparent container, will the rat inside the container still help the rat? Yeah, I mean, you can't just put a rat outside so it can go anywhere. So, you need another bigger container than that. And no, we haven't done that. We did do an experiment where we gave them a lot of distraction. We called it the toys experiment. And they still open. They're a little bit distracted, so they're a little delayed. They move around and they play with the toys for a little while, so it takes them a little longer to start opening, but they get there. And then they open, they sort of convert over to opening. Do you think violent or hostile interactions between the rats before the experiment could cause? Yeah, well, actually, we did that experiment. It was a horrible experiment. We all hated doing it. We didn't realize before we did it how unpleasant it would be, but we did a bullying experiment. There's a bullying paradigm called the resident intruder paradigm. And all the rats and all the experimenters, in fact, were very unhappy. So we hated doing it, and the rats just said, F this, we're not opening. So it didn't matter whether they were actually bullied or whether they were off. So it was a big room, and we'd take a cage, and there was 2 rats, and we put it off on the side, and we take one rat from the cage and put it in with the bully. And the other rat would just be sitting over there on the edge of the room, many feet away, many meters away. And none of them opened. It didn't matter whether he was bullied directly or he just was in the room when the bullying happened. So this goes to the previous question about stress. Stress is not conducive to helping. Oh, what if the rat cannot see what is inside and can only hear the trapped rat? So what is the thing that is telling them that the rat is distressed? That's a really good question, and we don't know the answer. My hunch is that it's a combination of smell, hearing, sight, and actually touch. What you'll see, I don't know if you saw, but the restrainer has a lot of holes. And what you see with the rats is that they engage each other with their whiskers, and they're doing a lot of touching. And I think that's probably a big player, but I don't know that. It's the whole, I suspect it's the gamish, the whole set of sensory stimuli. Great.
Thank you so much for taking in all those questions, ma'am. I'm sure everyone enjoyed them. I personally found your talk, keynote address, so mesmerizing. I was looking into all of the details, and me being from a psychology background, I completely understand why empathy is such an important measure, especially in today's world when we're trying to see when there are wars breaking out. We want to understand how human behavior could also be replicated, or rather why, what are the factors affecting this, and how we can ensure that we have environments in which we can, have more empathetic beings and produce environments where there are less stresses that can affect, probably the future of countries.
Yeah.
Thank you so much, ma'am.
Yeah. Thank you. Thank you all. And greetings to India. Maybe someday I'll see you in person. Be well.
Yes.
Thank you so much for
Okay.
joining in.
Okay. Thank you. Bye.
Bye-bye. Good night.
Right.
So,
We really hope that you were able to enjoy ma'am's speech. We will be starting the next, we will be having a break now from 1 to 2 p.m. But in that period, we'll be releasing 2-minute solution questions. The participants are mainly school children. This competition was held for school children, and they will be reading these questions and then trying to solve these questions in the coming week. And hopefully we'll have a lot of lovely entries for this competition, and we also have a lot of lovely prizes as well. Amartya, over to you, and then you can break us out for the break.
yeah, next talk we have Shubha Tole from Tata Institute of Fundamental Research in the Mumbai campus. And it will start at, up next we have a panel discussion at 2 p.m. and which is titled Neuroscience for All. And we're waiting for you guys to join, and maybe Shrestha will be coming up soon at 1 o'clock, and he'll be releasing the problem statements. So I'll keep the meeting on, so you can like you can be here, or you can join in before the next panel starts, which is at 2. Thank you for joining in.
Apologies, I messed up with the apologies, I messed up with the break. The break is at 2 o'clock. I saw the time wrong. Yes, we have the panel discussion coming in. We really look forward to all of you joining in for that. Neuroscience for All, diversity, and lovely conversations coming up.
Thank you so much. Wait, I think the break is from 1 to 2, and the panel discussion is from 2 to 3.
Oh, I'm so sorry.
Yeah, just making sure, like, the break is from 1 to 2, so you can just go and grab your lunch, and then you can join us back for 2 at 2 p.m. for the panel discussion. And you guys can stay on the meeting if you want. I'm keeping the meeting open.